Welcome. Last time, in part 1, we discussed Galileo sequences and how to see why that the particular Galileo sequence we wrote down always gave you the same value. So to recap, we said we took the first, say, 3 odd numbers, 1, 3, and 5. And then we took the next 3 odd numbers, 7, 9, and 11. And if we took the ratio of the sum of the first 3 odd numbers to the sum of the next 3 odd numbers, we noticed we always got 1/3, and the reason was, well, the first 3 gave you this square here, 3 by 3 square, and adding up the next 3 odd numbers gave you simply 3 copies of that original 3 by 3 square. And it didn't really matter that we were doing the first 3 odd numbers. If we'd have done the sum of the first n odd numbers, we would have had the same property. We would have had an n by n square, and then over here we would have had 3 n by n squares. So I wanted to, in part 2, give you a few more consequences of this geometric approach to looking at Galileo sequences. For instance, let's say we wanted to not look at the sum of the first n odd numbers over the sum of the second n odd numbers, but maybe the sum of the second n odd numbers over the sum of the third set of n odd numbers. Well, first thing we notice is that we don't actually need to worry about how many odd numbers we're adding up. All right? We're simply getting some square full of dots. And then before, for instance, we saw, okay, you took the first n odd numbers, and that gave you 1 square, and if you took the second set of n odd numbers, that gave you 3 more squares. Okay, and if we looked at the third set of n odd numbers, well, this would give us 2 on the side, 2 on the bottom, and 1 on the diagonal. And so we would get 5 sets. Right? 5 of these little squares. And so it becomes pretty obvious that if we want to compare the second set of odd numbers, the sum of these, to the third set, it's simply going to be the number of boxes, so 3 over 5. So this tells us that, say we add up the second set of 3 odd numbers. So we skip 1, 3, 5, and we do 7 plus 9 plus 11, and divide this by 13 plus 15 plus 17. Then the prediction is that this should give us 3/5. And let's see, well, 11 plus 9 plus 7, that's 27. And 13 plus 17 is 30, plus 15 is 45. And if you divide both of those by 9, you get 3 over 5. So, of course, we know from the original theory of how we built this box that we're going to be getting ratios of odd numbers here. So if we took, for instance, the sum of the first, or rather the third set of n odd numbers over the sum of the 10th set of n odd numbers, the ratio we would expect to be the third odd number, or 5, divided by the 10th odd number, or 19. 5/19. This should be the sum of the third set of n odd numbers divided by the sum of the 10th set of n odds. Okay. Alright, so this is one really nice application. Another that we can see pretty quickly is this. Let's say I'm going to start by adding the first 3 odd numbers, but then I'm going to subtract the next 3. And then I'll do the same thing on the bottom. I'll divide by the sum of the next 3 odd numbers. So we have 13, 15, and 17. And then I'll subtract the next 3 odd numbers, 19, 21, and 23. And what's pretty cool here is, all right, if I color in the boxes which are going to be added, and then I'll leave white the ones I'm going to subtract, what you can immediately see here is that the ones that you're going to subtract, okay, well, there'll be 2 more of those boxes. So really, I'm just getting negative 2 boxes. And, okay, let's see, we need to add one more row here. And, okay, well, first, these are going to get filled in, right? Because on the bottom, we're going to be adding the third set of odd numbers. But then we're going to be subtracting the following set. So we should get 7 of these big boxes. Mind you, each one of these boxes right now is representing actually 3 different rows. In this case, the 19, 21, and 23 rows. And again, right, we know that each one of these L's is going to have 2 more boxes than the previous one. So this gives you negative 2 boxes, where, again, the blacks are counted as positive and the whites as negative. And here on the bottom, you get negative 2 boxes. And so, in fact, we're getting negative 2 of these boxes divided by negative 2 of these boxes. And so, in fact, the quotient is simply going to be 1. All right, so a little exercise for you is try to extend this to where you might take, say, the first 3 minus, or the first box here minus the next box plus the next box, and then divide by, say, the negative of this line of L's, the positive, plus the positive of the next line, and then subtract. Just keep alternating the sign. And it shouldn't be hard for you to work out. Geometrically, it becomes very easy to see what's going on.